Now we will remove the sample from the low pressure port and determine the assembly mass. This mass represents the mass of the test portion of the penetrometer and of the mercury that was loaded into the penetrometer at the beginning of the low pressure analysis. This is generally before the mercury intrudes into the pores of the sample material. The temperature of the mercury can be used to determine the mercury density, and with the mass of mercury surrounding the sample, the mercury volume can be determined. Knowing the calibrated empty penetrometer volume and the mercury volume surrounding the sample, the volume of mercury displaced by the sample prior to intrusion is the bulk volume of the sample. Along with the sample mass, this allows calculation of the bulk density of the sample. Chris removes the capacitance detector assembly slowly in case mercury is leaked out of the penetrometer and into the detector assembly. The plastic trays below the low pressure ports are there to catch mercury in case a leak has occurred. He then loosens the low pressure port and removes the transparent retainer. Now Chris carefully slides the penetrometer from the low pressure port, being careful not to tip the penetrometer so that mercury doesn't pour from the end of the open stem. Since Chris is not starting another sample in low pressure port right away, he will seal the port with a filler rod with a transparent retainer and a detector assembly in place. The next step is to determine the assembly mass for the penetrometer just removed from low pressure. Since the penetrometer must be in the stem upward orientation, Chris will tare the balance and then set the penetrometer on its cap to determine the mass which he records. This mass will be entered when we begin the high pressure analysis.